A series of quiet moves is happening at the same time. Individually, each update feels small. Together, they completely change how Tesla builds cars, prices, cars, and competes in 2026. So here's what really matters: which of these technologies actually shows up in your next car. That's exactly what we're breaking down today. This video is a full recap of several deep dive episodes we've already released. So some parts may feel familiar, but the goal here is simple. Put everything in one place so you don't miss a single signal. If you like clear, numbers first. Tesla analysis without hype. Help us hit 27,111 subscribers. Tap like, subscribe, and let's get started. Tesla has just launched a brand new version of the Model Y in the United States. Sounds normal, right? Another trim, another price, another box you can tick on the configurator. But look closer, because this one is strange. It costs more than the cheapest Model Y. It goes less distance on a charge. And it sits awkwardly between trims that are objectively better deals. On paper, this car makes no sense. So if you're about to ask, is this Model Y worth buying? Stop. That's the wrong question. The real question is this: why would Tesla deliberately sell a worse car? And no, this isn't a mistake. It's not a pricing error. And it's definitely not Tesla being generous, because this car wasn't built for customers. It was built because Tesla is trying to protect something far more fragile than demand: its factories. Most videos will now throw a spec sheet at you. Rear-wheel drive versus all-wheel drive. Range numbers. 0 to 60 times. What speakers you lose. What seats you don't get. And if that's all you look at, you'll completely miss what's actually happening. Because this Model Y isn't a product decision. It's a production decision. And once you see why Tesla needs this version to exist, you'll never look at the Model Y, or the upcoming Model 2, the same way again. Why this Model Y shouldn't exist, and does anyway. Let's get specific. This new version is called the Model Y All-Wheel Drive, priced at $41,990. That's roughly $2,000 more than the base rear-wheel drive Model Y. Yet EPA-rated range drops from about 321 miles to roughly 294 miles. More money, less range. If this were Ford, Toyota, or Volkswagen, this trim probably wouldn't exist. For decades, the rule in the car industry has been simple: pay more, get more performance, more range, or more features. This version breaks that rule completely. And Tesla did it anyway. That's not an accident. The market's immediate reaction has been predictable. Tesla is expanding choice for buyers. That's the first misunderstanding. Because Tesla doesn't actually have a choice problem. It has a balance problem. And once you see what Tesla is trying to balance, you'll understand why this Model Y exists, and why Model 2 can't afford to be wrong. Tesla doesn't have a buyer problem. It has a factory problem. To understand this, you have to stop thinking like a car buyer and start thinking like a factory operator. Because on the buyer side, the Model Y is doing just fine. Even as the US EV market slowed through 2024 and into early 2025, the Model Y still moved roughly 350,000 units a year, by far the most dominant E5 in the country. To put that into perspective, most competing EVs are considered successful if they sell 30,000 to 50,000 units a year. The Model Y does that every single month. That's why industry estimates now show the Model Y alone accounting for close to 40% of all EV sales in the US. And when you add the Model 3, Tesla controls nearly 60% of the entire EV market. So no, this isn't about weak demand. And this is where most people get it wrong. Factories don't care about cooled seats, ambient lighting, or speaker counts. They don't care which trim YouTube reviewers recommend. Factories care about three things: parts availability, line flow, and utilization rate. Miss any one of those, and you don't just sell fewer cars, you break the system. Here's the part most people never think about. Rear-wheel drive and all-wheel drive aren't just different driving experiences. They're completely different production paths. All-wheel drive means an extra motor, different inverters, different wiring harnesses, different inventory pressure. That's not a small tweak. That's an entirely different parts balance problem. If Tesla misjudges the AWD to RWD mix by even a few percentage points, the consequence isn't a bad quarter. It's thousands of unfinished cars sitting inside factories, waiting for the wrong component, blocking space, breaking takt time. And in manufacturing, a factory running unevenly is worse than one running slowly. This is why Tesla doesn't just need demand. It needs predictable demand. It needs a way to gently push buyers in one direction without cutting prices and blowing up the entire lineup. And this new Model Y AWD is exactly that. Now notice something very telling. This version isn't optimized to be the best deal. It's optimized to be just acceptable. Acceptable to a very specific buyer. Someone who lives in a snowy or wet climate, wants AWD for traction and peace of mind, but still watches the price carefully. For that buyer, losing 25 or 30 miles of range isn't a deal breaker. For Tesla, every one of those buyers does something far more important. They help absorb surplus AWD components, smooth production scheduling, avoid cutting prices on premium trims. This isn't a great deal. It's a pressure relief valve for the factory. And here's where this should start to feel personal. If you already own a Model Y, this trim tells you Tesla is protecting factory stability, not resale value. If you're shopping for a Model Y right now, this trim exists to quietly steer your decision. And if you're waiting for Model 2, this is Tesla showing you just how unforgiving their production math has become. So ask yourself, are you buying the car that makes the most sense for you? Or are you helping Tesla solve a factory problem? Drop a comment below. Which one are you? Current owner, potential buyer, or waiting for Model 2? Model Y is being bent because Model 2 cannot be wrong. Now compare this approach to Tesla's competitors. Ford offers a clear contrast. Over the past several years, Ford has repeatedly reduced Mustang Mach-E pricing by thousands of dollars per vehicle, using direct discounts to correct inventory and demand imbalances. Volkswagen takes a different approach. When EV demand softens, VW has shown a willingness to pause or slow EV production at specific plants, rather than reshaping the product itself. Tesla doesn't like doing any of that. Tesla adjusts the product. That's a very Silicon Valley way of thinking. Change the interface, not the back end. And timing matters. The Model Y is no longer a halo product. By 2025, it has become a mature, high-volume platform. It's the workhorse keeping Tesla's factories running while the company prepares its next phase. And that next phase is Model 2, a vehicle widely expected to define Tesla's next growth cycle heading into 2026. A car that cannot afford to be wrong. If Model 2 slips, Model Y must carry volume. If Model 2 launches aggressively on price, Model Y must anchor the lineup. Which means Model Y isn't just a car anymore, it's a buffer. Tesla could have simply discounted the premium all-wheel drive Model Y. But Tesla already knows what aggressive pricing does. Over the past 2 years, Tesla has repeatedly adjusted prices across global markets, in some cases by double-digit percentages, resetting customer expectations almost overnight. Do that again, and existing owners feel burned. Brand trust takes a hit. Wall Street reads it as weak demand. Tesla wants none of that. So instead of lowering prices directly, they introduce a trim that looks slightly awkward. Good enough to sell, not good enough to cannibalize. This strategy isn't new. Henry Ford famously limited color choices because factories couldn't handle variation. Toyota spent decades restricting trim complexity to protect production flow. Even today, legacy automakers hide this logic behind dealer packages. Tesla just does it in public. And when a product starts gaining too many trims, something important happens. It stops being a product. It becomes infrastructure. The Model Y now behaves less like a car and more like a modular production tool. Tesla isn't asking, what does the customer want? It's asking, what keeps the line running cleanly? That's why asking whether this Model Y is worth it misses the point. The better question is this: what problem is Tesla trying to avoid? And the answer is volatility. Volatility in demand, volatility in pricing, volatility in production rhythm. This trim exists to keep everything else stable. Now here's the uncomfortable implication. And this is where you come into the picture. If you already own a Model Y, this should make you pause, because it tells you Tesla is protecting factory stability, not your resale value. If you're shopping for a Model Y right now, this trim exists to quietly steer your decision. And if you're waiting for Model 2, this is Tesla showing you just how unforgiving their production math has become. This isn't a story about a bad trim. It's a story about a company choosing factory stability over product purity. So this Model Y isn't really for you. It's for the factory. It doesn't tell a story about features or value. It tells a story about constraints. And if factories now matter more than the cars themselves, here's the real question I want you to answer in the comments. Is Tesla still primarily a car company? Or is it becoming a manufacturing systems company that just happens to sell cars? Because the answer to that question will define not just when Model 2 launches, but how Tesla behaves for the next decade. This is exactly the kind of thinking we break down on AWD. Not specs, not hype, but the system behind the machine. And in the next videos of this series, we're going deep into Model Y itself, the hidden trade-offs, the ownership mistakes people don't realize they're making, and the small decisions that actually change long-term cost and experience. If you own a Model Y, are thinking about buying one, or are waiting for Model 2, you don't want to miss that.
This is a really super important car for Tesla. It is the company's best-selling model, and it is among the top sellers of any EVs going.
In early 2026, Tesla started adjusting its most popular vehicle in a much subtler way than the dramatic launches fans have come to expect. Over the past few days, a series of updates connected to the Model Y, especially the Juniper refresh that defines the 2026 generation, have surfaced. In this piece, we'll break down the most recent confirmed Model Y updates in the first quarter of 2026, separating real signals from speculation and setting the stage for what's next in Tesla's best-selling SUV. Why did Tesla quietly introduce a lower-cost all-wheel drive Model Y in early 2026? One of the most notable updates appearing in the first quarter of 2026 is the introduction of a new all-wheel drive version of the Tesla Model Y in the United States, priced at about $41,990. This isn't just a minor change in the configurator, it represents a shift in Tesla's pricing strategy for its most important product line. The new all-wheel drive variant sits above the entry rear-wheel drive model, creating a more accessible step for buyers preferring all-wheel traction without paying a premium price. What makes this update significant is not only the entry price, but also the broader context. Tesla's 2025 pricing strategy had already introduced lower-cost standard trims for both the Model 3 and Model Y to attract more cost-conscious buyers, especially after the U.S. federal electric vehicle tax credit of $7,500 expired in late 2025. By dropping the standard name and repositioning trims by function rear-wheel drive, all-wheel drive, premium Tesla seems to be simplifying its lineup while embracing more competitive pricing. Now that Tesla has quietly updated the Model Y lineup, including a more affordable all-wheel drive option, do you think this makes Tesla more appealing to everyday car buyers? Or do you still see major gaps versus traditional automakers? Type yes if you feel these changes make Tesla a better choice today, or no if you think there's still work to be done. More importantly, this pricing adjustment is happening at the same time that the wider electric vehicle market is under pressure. Sales growth for electric vehicles has cooled in some key regions, and competitors are aggressively positioning their own SUVs and crossovers with attractive pricing and features. By presenting a new mid-tier all-wheel drive Model Y in the $41,000 to $43,000 range, Tesla is signaling an intent to keep volume flowing through the Model Y line rather than relying solely on high-end trims. From a strategic perspective, this update bridges two goals: retaining mainstream affordability and maintaining the Model Y's appeal as a practical family SUV. For buyers considering the Juniper refresh, it illustrates that Tesla is prioritizing real-world ownership costs and accessibility as much as headline performance figures. What does Tesla's new Model Y trim naming really tell us about its 2026 strategy beyond the introduction of a cheaper all-wheel drive variant? Tesla also made a broader structural change to how the Model Y lineup is presented in early 2026. The company quietly removed the long-used standard naming convention and simplified its trims to functional labels rear-wheel drive and all-wheel drive. While this may appear cosmetic at first glance, it reflects a deeper recalibration of how Tesla wants buyers to perceive value, capability, and price separation within its most important vehicle line. According to Electrek and Teslarati, the newly positioned all-wheel drive Model Y now sits at roughly $42,000, which is approximately $6,500 to $7,000 cheaper than the all-wheel drive long-range trim it effectively replaces. This is a meaningful shift in a segment where price sensitivity has increased sharply since late 2025, especially following changes to U.S. federal electric vehicle incentives. Instead of pushing buyers directly from a low-cost rear-wheel drive model to a much more expensive premium all-wheel drive version, Tesla has narrowed the price gap to roughly $3,000 to $3,500. That alone lowers the psychological barrier for buyers considering all-wheel drive for climate or safety reasons. The range figure attached to this cheaper all-wheel drive trim is listed at approximately 294 miles EPA, down from the 330-plus miles previously associated with the higher-end all-wheel drive long-range configuration. While that reduction looks significant on paper, the underlying implication is more nuanced. At an average Model Y energy consumption of roughly 260 to 270 watt-hours per mile, a 294-mile rating implies a usable battery capacity in the neighborhood of 70 to 72 kilowatt-hours, compared with the roughly 75 to 78 kilowatt-hours packs used in prior all-wheel drive variants. That difference of around 5 to 8 kilowatt-hours per vehicle is strategically important at scale. At estimated battery cell costs of $80 to $100 per kilowatt-hour in early 2026, trimming 5 to 8 kilowatt-hours from each pack could reduce battery cost by approximately $400 to $800 per vehicle. When applied across hundreds of thousands of Model Y units annually, this change gives Tesla meaningful flexibility. It can either protect margins in a tightening market or pass savings directly to consumers through lower pricing. Reuters has repeatedly framed Tesla's recent pricing moves as part of a broader effort to sustain volume and factory utilization amid slowing electric vehicle demand growth, rather than chasing maximum per-unit profit. Crucially, the real-world impact of the reduced range is limited for most buyers. Department of Transportation travel data shows that over 95% of daily vehicle trips in the United States are under 100 miles, meaning that a sub-300-mile EPA rating still comfortably covers typical daily use with wide margins. By accepting a modest reduction in headline range, Tesla appears to be prioritizing affordability, manufacturing efficiency, and lineup clarity, all of which align closely with the broader goals of the Model Y Juniper refresh. Why did Consumer Reports choose the Model Y as the best electric vehicle for 2026? One of the strongest recent signals about where the Tesla Model Y stands in the current electric vehicle landscape comes from an independent authority that U.S. buyers, especially more skeptical or practical buyers, trust deeply. Consumer Reports. In its latest top picks list for 2026, Consumer Reports placed the Tesla Model Y at the top of the electric vehicle category, effectively naming it the best electric vehicle for the 2026 model year. This ranking comes from a rigorous evaluation process that goes beyond just range and acceleration, incorporating real-world road testing, reliability data, owner satisfaction surveys, and safety performance, all without any influence from automakers themselves. The publication specifically notes that the refreshed Model Y blends practicality with performance, a usable hatchback design that accommodates families and cargo, strong real-world range figures, and continued access to the widespread Tesla supercharger network. The Model Y also benefits from recent improvements in ride comfort and interior quality, including enhanced acoustic glass and refined suspension tuning, which address long-standing critiques of earlier versions of the SUV. The recognition also comes at a time when the electric vehicle segment is diversifying rapidly. Legacy automakers are pushing electrified platforms, and competitors such as Ford, Toyota, and Subaru are increasingly prominent in overall vehicle rankings. Yet even amid that broader competitive landscape, the Model Y stands out in a pure electric vehicle category, underscoring Tesla's ongoing relevance and resonance with mainstream drivers. In sum, the Consumer Reports endorsement doesn't just tell us that the Model Y is good, it tells us that in the context of 2026's wide range of vehicles across price points, technologies, and design philosophies, the Tesla Model Y remains one of the most compelling choices for buyers who want a real-world capable, well-rounded electric SUV backed by independent evaluation. That's a powerful signal of product maturity and market credibility for the Juniper-era Model Y. Why did China move to ban hidden door handles? And how could this affect the Model Y? In a story that might seem unrelated at first glance, China's Ministry of Industry and Information Technology recently announced a regulation banning hidden or electronically controlled only door handles on new vehicles sold from January 1, 2027 onward. This rule, prompted by safety concerns, after incidents where occupants could not exit vehicles due to malfunctioning electronic door systems, mandates that cars must have mechanical release handles both inside and out. At first glance, this may look like a regional peculiarity, but it's emblematic of how regulatory pressures can shape global design trends. Tesla's minimalist flush handles have been an aesthetic and aerodynamic hallmark of its vehicles, including recent Model Y refreshes in many markets. Though the regulation applies initially only to China, it could influence design thinking elsewhere, especially if other major automotive markets adopt similar safety criteria. For the Model Y, Juniper, and future electric vehicle refreshes, this development suggests a subtle interplay between design, ambition, and practical regulatory realities. Hidden or flush handles improve airflow and contribute to a sleek appearance, but they also introduce potential fail points in emergency situations. Regulators temper design decisions with usability and safety requirements, and manufacturers that sell cars globally may choose to harmonize their designs to meet the strictest standards rather than maintain different variants by region. Thus, even design details that seem purely stylistic can have broader strategic implications. If Tesla's next refreshes, Juniper follow-ons, or future generations are influenced by these regulatory trends, we might see design cues evolve to balance safety, usability, and efficiency. That's a reminder that global electric vehicle strategy isn't only about batteries and range, it's also shaped by the policy environments in which these vehicles are sold.
So it's finally here. A battery that is cheap and available.
Most EV headlines focus on range, acceleration, or software updates. But every EV owner, especially older buyers, cares about two things more than anything else: how long the battery lasts, and how painful charging really is. Now, a new battery claim is circulating that sounds almost unreal. 1.8 million miles of lifespan, 600 kilowatt charging, and a battery that could outlast its owner. This isn't a Tesla announcement, it's coming from CATL, the world's largest EV battery supplier. So what exactly is this new battery technology? Why is CATL confident it can survive extreme fast charging without destroying long-term battery health? And more importantly, how does this kind of battery fit into Tesla's world, where cost, scale, and manufacturing control matter more than headline specs. To understand why this battery is getting so much attention and what it could realistically mean for Tesla's future models, we need to break it down step by step. What is this new battery, and why people are paying attention? From the moment Contemporary Amperex Technology Co., Limited, better known as CATL, unveiled its next-generation lithium-ion battery technology, the headlines were impossible to ignore. What caught attention wasn't just the promise of longer range or faster charging, but an audacious claim that this new battery could be charged in roughly 12 minutes and still retain 80% of its capacity after what equates to nearly 1.8 million kilometers of driving. For anyone who has watched an electric vehicle's range slowly fade year after year, or has grimaced through a charger session that eats up half an hour of your day, these numbers hit at the deepest anxieties many EV owners carry. To put it in perspective, 1.8 million kilometers is almost 6 times what most EV batteries are designed to endure before significant degradation kicks in. According to company data and reporting from international outlets, the new CATL battery, branded around a 5C rating, retains roughly 80% of its capacity after 3,000 full charge. Discharge cycles under controlled conditions, translating to that striking mileage estimate, even under extreme thermal stress conditions equivalent to a desert summer around 60 degrees Celsius. CATL claims the chemistry still holds at about 80%, after some 1,400 cycles, roughly 840,000 kilometers, without rapid loss of usable energy. Whether this battery ultimately performs exactly as advertised in everyday use remains to be seen. Mass production schedules and independent third-party validation have not yet been released, but the fact that the industry's largest battery maker is claiming these milestones at all signals, something that even casual EV enthusiasts feel viscerally. We might be approaching a point where battery life and charging speed are no longer the core limitations for the next generation of electric cars, but rather solved engineering constraints that open the door to new design priorities and customer expectations. We've all seen bold battery promises come and go, impressive headlines, limited real-world impact. Does this feel like a genuine turning point, or just another claim you've learned to be cautious about? Comment yes if this feels different, or no if you're still not buying it. How CATL pulled this off? What makes CATL's announcement genuinely disruptive is not any single headline number, but the way those numbers coexist without collapsing into the usual trade-offs. In battery engineering, longevity, fast charging, and thermal stability normally pull against one another. Pushing one almost always compromises the others. CATL's claim is that it has bent, if not broken, that triangle, and understanding how requires looking beyond surface chemistry names and into how the cell is built, protected, and managed at scale. According to CATL-linked disclosures analyzed by Clean Technica and Battery Tech Network, improvements in cathode coating, uniformity, and electrolyte formulations are key to suppressing these degradation pathways even at high C rates. This is where the 5C without killing the battery claim becomes more plausible. Under extreme, fast charging, lithium ions can fail to intercalate cleanly into the graphite structure of the anode, instead depositing as metallic lithium. Over time, that process permanently removes active lithium from the system, reducing capacity and increasing internal resistance, the silent killer of battery longevity. CATL's work appears focused on maintaining ion transport stability under high current density, using electrolyte additives and microstructural controls to keep lithium moving where it's supposed to go. Electrive's reporting notes that CATL emphasizes thermal uniformity at the cell level as much as chemistry, suggesting that heat gradients often overlooked in spec sheets are treated as first-order design constraints rather than secondary concerns. For Tesla, which already relies on CATL for LFP cells in multiple global markets, this is not a hypothetical dilemma. It is an active strategic question. CATL's battery does not merely compete with Tesla's in-house roadmap. It reframes the problem Tesla is trying to solve. Tesla and CATL. CATL has been supplying lithium iron phosphate battery cells for Tesla since 2020. Initially for Model 3 vehicles built in Shanghai, before expanding to Model Y and select European markets. Tesla confirmed the strategic importance of CATL-supplied LFP packs during its Q3 2020 and Q1 2021 earnings calls, framing LFP as a key enabler for cost control and volume scaling rather than performance leadership. By 2022, Tesla had shipped well over 1 million vehicles globally using CATL batteries, primarily in standard range trims of Model 3 and Model Y, making CATL not a marginal supplier but a foundational pillar of Tesla's mass market lineup. This partnership was not driven by technology novelty, but by reliability at scale. CATL's prismatic LFP cells offered predictable yields, stable pricing, and lower supply chain risk at a time when Tesla was aggressively expanding production capacity in China and Europe. In other words, CATL helped Tesla solve a manufacturing problem, not a marketing one, ensuring Tesla could keep factories running at volume without exposing itself to volatile nickel and cobalt supply constraints. At the same time, Tesla has spent the past 5 years actively working to reduce long-term dependence on external battery suppliers. This intent became explicit at Tesla's Battery Day in 2020, when the company unveiled the 4680 cell and outlined a roadmap centered on in-house manufacturing, dry electrode processing, and structural battery packs. Since then, Tesla has invested billions into pilot lines in Fremont and Austin, publicly acknowledged yield challenges during 2022 and 2023 earnings calls, and repeatedly emphasized that battery manufacturing is one of the hardest problems it is trying to solve. These efforts make Tesla's position clear. Batteries are not just consumables to be sourced, but core architecture that determines vehicle cost, rigidity, and manufacturing efficiency. Even when progress has been slower than originally projected, Tesla has doubled down rather than retreated, adjusting timelines, renegotiating supplier contracts, and reprioritizing internal cell development. This history matters, because it shows that Tesla's hesitation to fully outsource batteries is not ideological stubbornness, but a calculated bet that long-term control will outweigh short-term advantages. The real impact of CATL's battery is not whether Tesla adopts it immediately. It is that the benchmark has moved. When a supplier can plausibly claim that the battery will outlast the car itself, Tesla is forced to reevaluate what differentiation really means in the next phase of EV adoption. The competition is no longer about who has the most advanced battery on paper, but who delivers the least friction, the least anxiety, and the longest usable life to ordinary drivers. How would Tesla actually use this battery? If Tesla were to use a battery from CATL in future vehicles, the most dramatic change would not show up on a spec sheet. It would show up in how ownership feels day after day. For a Model 2 type vehicle, battery choices would likely be driven by cost per kilowatt hour and durability rather than peak performance. Based on current LFP pack pricing trends in China and Europe, industry estimates suggest pack-level costs in the range of $65 to $80 per kilowatt-hour by 2026, assuming continued scale and stable raw material pricing. For a compact vehicle targeting a 40 to 50 kilowatt-hour usable pack, this implies a battery cost window of roughly $2,600 to $4,000 per vehicle, a threshold that makes a sub-$25,000 price point structurally feasible rather than aspirational. LFP chemistry would also align with Tesla's expected ownership profile for a mass-market vehicle, with typical cycle life estimates of 3,000 to 4,000 full charge cycles. Even a conservative 250-mile real-world range would translate into 750,000 to 1 million miles of theoretical pack life. While few vehicles would ever reach that figure, the implication is clear. Battery degradation would be a secondary concern for most first and second owners, supporting Tesla's long-term cost of ownership narrative rather than short-term range marketing. Model Y, Juniper, expected to refresh Tesla's highest volume global platform, would likely continue to prioritize efficiency and manufacturing simplification rather than radical battery chemistry shifts. Current Model Y long-range variants deliver EPA-rated ranges around 310 to 330 miles. Incremental improvements from revised aerodynamics, power electronics, and potential structural pack refinements could reasonably push usable highway range gains of 5 to 8%, rather than dramatic leaps. In practical terms, this means Model Y Juniper would remain optimized for frequent, predictable charging behavior, not marathon single-leg drives. Tesla's supercharger network, now exceeding 50,000 fast chargers globally, reduces the marginal value of extreme range while rewarding faster charge curves and thermal stability. For regular road trip users, the experience would likely feel less about driving farther between stops, and more about shorter, more consistent charging sessions, a trade-off Tesla has increasingly favored as its vehicles move from early adopters to mainstream households. If CATL's battery delivers even part of what it promises, it doesn't just challenge competitors, it challenges how we think about owning an electric car. A new battery chemistry is quietly moving from the lab to real cars, and it could cut electric vehicle battery costs from around $55 per kilowatt hour to as low as $19 per kilowatt hour. It handles freezing winters better than lithium, uses cheaper materials, and several automakers in China are already putting it into production vehicles, not prototypes. So if sodium batteries make electric vehicles thousands of dollars cheaper, which cars get them first? Could this finally bring truly affordable electric vehicles under $20,000? And more importantly for us, how would Tesla and Elon Musk react? Especially with Model Y Juniper on the market and the upcoming Model 2 development, that's exactly what we're breaking down today. One, who's putting sodium batteries into real electric vehicles first and why 2026 could change cold weather driving. For years, sodium-ion batteries have sounded like one of those next big things that never quite leave the lab. Good on paper, interesting chemistry, but always 5 years away from real cars. That's what makes the latest development different because this time, it's not a prototype announcement or a research paper. It's production vehicles, winter testing, and a clear commercialization timeline. The world's largest battery maker, CAT, has officially partnered with Chang'an Automobile to push a full sodium battery strategy into the passenger electric vehicle market. Not commercial vans, not low-speed city carts, but real passenger vehicles that people can actually buy. And instead of doing mild climate tests in controlled environments, they chose one of the coldest regions in China, Yakeshi, Inner Mongolia, a place known in the industry as a serious cold weather proving ground. That choice alone tells you what problem sodium is trying to solve. Anyone who has owned an electric vehicle in a northern climate knows the issue. Lithium batteries hate the cold, range drops, charging slows down, and the car spends energy just heating the pack. In some cases, you can lose 20, 30, even 40 miles of usable range on a freezing morning. That's not a small inconvenience, that's the difference between making it home or stopping to charge. Sodium chemistry behaves differently. It retains capacity far better at low temperatures, which means less performance loss when the thermometer drops below -10 or -20 degrees Celsius. So instead of hiding from winter testing, CATL and Chang'an are leaning into it, basically saying, if it survives here, it survives anywhere. The first models scheduled to receive CATL's sodium packs are Chang'an's Ocean-branded passenger vehicles. These are mainstream, everyday cars aimed at normal buyers, not niche experiments. That matters because it signals confidence. Automakers don't risk their core products on unproven tech unless they believe it's ready. At the same time, other Chinese manufacturers are lining up. GAC, the company that builds electric vehicles for Toyota in China, is expected to integrate sodium batteries into upcoming models. JAC is also joining the next wave of testing and deployment. So this isn't a one-company gamble. It's starting to look like an ecosystem shift, with multiple brands preparing to adopt the same chemistry. Behind all of this is CATL's new sodium battery line, often referred to by its brand names like Noxine or Noxtra. On paper, the numbers are already practical, not theoretical. Energy density is rated at around 175 watt-hours per kilogram. Now, that's lower than the best lithium iron phosphate packs. But it's not unusable. It's actually right in the range that works fine for standard range commuter cars and city vehicles. CATL has also emphasized durability and safety. The chemistry is designed to operate reliably in extreme temperatures and is certified under China's latest national battery safety standard, GB 38031-2025. For everyday drivers, that translates into fewer thermal management headaches and potentially fewer long-term degradation concerns. Less stress on the pack usually means longer usable life. And here's where it gets even more serious. CATL isn't treating this as a limited pilot. They've publicly stated that sodium-ion batteries are scheduled for large-scale deployment in 2026. That rollout is expected to cover passenger cars, commercial vehicles, battery swapping systems, and even grid-level energy storage. When a supplier as big as CATL commits to multiple sectors at once, it usually means the supply chain is already being prepared: factories, materials, automation, everything. Because remember, CATL isn't a startup experimenting with chemistry. This is the biggest battery producer on the planet. When they flip a switch, millions of cells follow. A new battery chemistry only matters if it can be produced cheaply and consistently. Otherwise, it stays stuck in specialty products. CATL clearly wants sodium to sit alongside lithium, not replace it, but complement it, especially in segments where cost and cold weather reliability matter more than maximum range. So instead of positioning sodium as some miracle technology that replaces everything, they're being pragmatic. Use lithium where you need higher energy density. Use sodium where you need lower cost and better winter performance. Because once multiple automakers start launching affordable electric vehicles with good enough range and much lower battery costs, the entire pricing floor of the market begins to shift. Suddenly, entry-level electric vehicles don't have to cost $30,000. They can start pushing lower. Right now, the first wave is local. Chang'an, Oshan, Yak. But if the chemistry proves reliable through these winter trials and the 2026 mass production target holds, it won't stay regional for long. Other global automakers will start asking the same question: if CATL can supply a cheaper, cold-resistant battery at scale, why wouldn't we use it? At that point, sodium stops being an experiment and starts becoming an option on the table next to lithium iron phosphate and nickel manganese cobalt. And whenever a cheaper option lands on the table, the entire industry pays attention, especially Tesla. So, is a $19 per kilowatt-hour sodium pack the trick that makes a $25,000 Tesla Model 2 possible? Once you move past the chemistry and the winter testing headlines, the real story behind sodium batteries is simple cost. In an electric vehicle, the battery isn't just another component, it is the cost structure. Today, even the cheapest lithium iron phosphate cells still average around $55 per kilowatt-hour at the cell level. That's already considered low cost. CATL's sodium-ion target changes that equation dramatically, with a long-term goal of about $19 per kilowatt-hour. That's not a small improvement. That's a different pricing tier entirely. Run the math using a normal pack size. Most standard range crossovers and compact electric vehicles sit around 45 to 60 kilowatt-hours, so let's use 50 kilowatt-hours. At $55 per kilowatt-hour, that battery costs roughly $2,750. At $19 per kilowatt-hour, the same capacity drops to about $950. That's an immediate difference of $1,800 per vehicle. And that's only the cells themselves. Sodium also reduces system complexity. Lithium packs in cold climates need more heating, insulation, and active thermal management. Sodium tolerates low temperatures better, meaning less hardware and simpler pack designs. Realistically, total savings could approach $2,000 or more per car once everything is included. Now scale that across production. At 500,000 vehicles, you're talking roughly $1 billion saved. At 1 million vehicles, that's $2 billion. That's why CATL and multiple automakers are pushing this chemistry aggressively. These aren't engineering tweaks, this is billion-dollar math. There's also the supply-side advantage. Lithium prices have historically been volatile, swinging with demand and mining constraints. Sodium is abundant and cheaper, which means more stable and predictable costs. For automakers planning multi-year pricing strategies, predictability is often just as valuable as performance. The key point is that sodium isn't trying to beat lithium on range. It's trying to win on economics. It fits vehicles where 250 to 300 miles of real-world range is already enough, and where buyers care more about affordability than maximum specs. That makes it ideal for entry-level electric vehicles, commuters, fleets, taxis, and high-mileage daily drivers. For these customers, shaving $2,000 off the sticker price often matters more than gaining another 40 miles of range. This is where Tesla's lineup naturally splits. Take Model Y Juniper first. Juniper is positioned as a global family crossover sold across the U.S., Europe, and China. Buyers expect strong range, flexibility, and road trip usability. In those markets, losing range to use a lower density battery could hurt more than saving $2,000 helps. Sodium's 175 watt-hours per kilogram energy density is usable, but still below optimized lithium packs. And for a vehicle competing heavily on efficiency and miles per charge, that trade-off may not make sense. Tesla might experiment with sodium for a base trim or regional fleet version, but for the core Juniper models, lithium remains the safer and more logical choice. Now compare that with Model 2. Tesla's upcoming compact designed around a roughly $25,000 price target. This is a completely different mission. Model 2 isn't about long-distance travel or premium positioning. It's about volume and affordability, competing directly with lower-cost Chinese electric vehicles. At that price point, every $1,000 matters. If Tesla can remove $1,800 to $2,000 from the battery cost alone, that's massive. It could allow Tesla to price closer to $20,000, $22,000, or keep the price at $25,000 and significantly improve margins, or reinvest the savings into better software and autonomy hardware. At scale, the impact compounds fast. 1 million Model 2S with $2,000 lower battery costs equals $2 billion in savings. That's not a rounding error that directly affects profitability and growth. And strategically, this wouldn't be new behavior for Tesla. They already shifted many standard range vehicles to lithium iron phosphate batteries, choosing lower cost and durability over maximum energy density. Sodium would simply be the next logical step in that same philosophy use, the cheapest chemistry that delivers good enough real-world range. So here's the bigger picture. Sodium isn't trying to beat lithium on range, it's attacking cost. And saving $1,500 to $2,000 per car isn't a small tweak, it's a strategy shift. For Model Y Juniper, lithium still makes sense longer range, stronger resale, fewer compromises. But for a mass-market Model 2, sodium could be the key to a real $25,000. Tesla, so what would you choose, more range, or $2,000 back in your pocket? If BYD ships a 500-mile solid-state electric vehicle before Tesla, the narrative flips overnight, not because of range, because of cost. In 2026, solid-state isn't about hype anymore. BYD, Donut Lab, and QuantumScape are running pilot lines. And what about Tesla? Are they preparing quietly, or strategically waiting for the economics to break in their favor? Today, we're breaking down the real signals behind Tesla's solid-state strategy, how close competitors like BYD and QuantumScape are to true scale, and the exact cost, volume, and durability numbers that would force Tesla to move. If you want serious Tesla analysis without noise, subscribe and turn on notifications. We're pushing toward 24,999 subscribers, and this shift is just getting started. For solid-state batteries in 2026, the real battlefield is not chemistry. It is scale, cost, and timing. And when those three align, that is when Tesla moves. The question is not if, it is when. We will follow every movement of Tesla. So make sure to follow our channel not to lose track.